So our keynote this morning from Matt at Twitch. Twitch is pretty interesting. A lot of people in the room may not know who Twitch is because they might not be into gaming. But for all the talk that we hear about the Olympics and the World Cup and the US Open and all these sporting events, Twitch is actually one of those companies that is doing more live simultaneous streams than anybody else on the internet. So just to give you an example, last season's League of Legends championship broadcast, Twitch peaked at 8.5 million simultaneous streams. The Olympics was like 800,000. Not to take away from the Olympics, it was a good event. But Twitch is broadcasting some of the largest stuff on the internet today. Also, depending on whose statistics you look at in terms of internet traffic, Twitch is anywhere between now 4 and 5% of total peak internet traffic at night. So they're clearly growing. So Matt's going to talk today about what Twitch is. He's going to show some videos. He's going to talk about the platform. And Matt's background, he used to work at Ford Motor Company doing satellite distribution and audio fingerprinting. And before that, for those that have been in the industry for a long time, they'll remember the company Move Networks. Matt was at Move Networks working on technology there. So with that, please join me in welcoming Matt.
Great, thank you. Am I on? Is it working? Okay, thank you. Thank you, Dan. I can go ahead and skip my introduction since Dan did such a good job there. I'm going to go right into Twitch. So what is Twitch? Twitch is the world's leading video platform where gamers gather to broadcast, watch, and chat about video games. Twitch's video platform is the backbone of both live and on-demand distribution for the entire video game ecosystem. This includes game developers, publishers, events, user-generated content, and the entire esports scene. So the history of Twitch, it actually started in 2005 with the formation of Justin TV. Justin TV, for those of you not familiar, was originally a live streaming service for one of the founders, Justin Kan, who broadcast his daily life 24 hours a day, 7 days a week. And in 2007, Justin himself stopped live streaming, and the platform was opened to the public, and people were invited to broadcast using the developed infrastructure. At this time, the new content that was being broadcast, we grouped it into categories such as entertainment, news, sports, and of course, gaming. Emmett Shear, who was also one of the original founders of Justin TV and is currently CEO of Twitch Interactive, is a fan of the video game StarCraft, and he was watching a lot of streams of people playing on the Justin TV website. So the company started reaching out to these gaming users and asking them what sort of features that they would like to see in the platform. These features were developed and integrated, and in 2011, Twitch was spun off into its own site, into its own brand. So usually the next question I always get asked is, watching someone play video games, it seems kind of crazy. But we do assert that gaming is a social experience. Back at the arcade, people would line up to watch over people's shoulder while they're playing a new game. Crowds would form when high scores were reached. When games became home entertainment with consoles like Intellivision and Atari, they usually shipped with multiple controllers. You'd watch your friends play while waiting your turn. So what do people generally watch on Twitch? One of the largest popular forms of content is known as esports, and a subgenre of that is known as a multiplayer online battle arena, or MOBA. The most popular games in this genre are probably Dota 2, StarCraft 2, and League of Legends. Typically, these games consist of two opposing teams whose goal it is to destroy their enemy's base. The biggest game, lost track of my notes. These games foster large competitions between teams all over the world who compete in tournaments. The United States government actually offers athletic visas for foreign contenders to travel and compete in America. These events are massively popular. So this photo was taken from the League of Legends World Finals, which was held in the LA Staples Center last year. They sold out all 15,000 seats in under an hour. The events are covered and commentated on pretty much like traditional sports are. I took this clip from the League of Legends Championship series that aired on Friday. And if there's anyone on this stream who's a diehard fan, the text does not match. I cheated on this slide. But Twitch is not exclusively esports. There's a lot of other common formats. Speedruns, which are my personal favorite, where players compete against each other for points and time. A lot of new world records have been set on Twitch for a lot of many video games, both classic and modern. Another thing that's extremely popular is what the community simply refers to as Let's Play, where a broadcaster just casually plays a game while interacting live with their viewers. Twitch has also become a major part of the game development and marketing ecosystem, where publishers and developers have an opportunity to communicate with their fans. So where are people watching this content? Primarily our website at twitch.tv, but we do have official apps on Android and iOS, of course, and we also have apps on all the major new consoles, including Xbox One, PS4, and Xbox 360. We've announced but not yet released the Amazon Fire TV app, and we have apps on some smaller devices like the Ouya, which is a $99 Android-based gaming console that was launched on Kickstarter, and a handheld from NVIDIA called the Shield. The PlayStation devices, the PlayStation Xbox is actually set up at the Streaming Media Pavilion with our app installed, so you can check it out over there after the keynote. With Twitch, though, you don't need an account to watch, but signing up for a free account allows you to broadcast. Every user is given an RTMP endpoint that, using any RTMP-compatible software, they can broadcast to. I personally tend to group our broadcasters into several categories. First, we have PC broadcasters. This group tends to be a little more technical than the average person. They're largely PC gamers who have assembled their own computers with high-end GPUs and CPUs with gaming and streaming specifically in mind. Some people will use secondary computers with capture cards or external encoding hardware to take the encoding resources off of their CPU. This option also gives them the ability to mix in external sources such as older gaming consoles or high-quality cameras. For the software side, the most popular tools are XSplit and open broadcast software, excuse me. If you're not familiar with these are free third-party applications that run on a PC. They're essentially minimal production studios, and they allow for a lot more customizability than a standard like in-browser Flash broadcaster can do. You can include input from multiple sources, including screen buffer for screen capture, multiple webcams, capture cards. They have support for a lot of advanced features like overlays, chroma key, alpha blending, OpenGL effects, etc. This category of software is largely driven by Twitch and its users who've come to expect a little higher production value from the user-generated content on our site. The next category that I like to think of is our one-click broadcasters. This is a relatively new group for us. The latest generation of gaming hardware is shipping with Twitch streaming integrated directly into the interface. To highlight a couple here, we have the NVIDIA GeForce ShadowPlay. This is a hardware-software combination that's available on select NVIDIA graphics cards that have the NVENC AVC encoder built in. This software will capture the video of your gameplay and store it to disk or stream it out to Twitch Live. Also is the Sony PlayStation 4, which was shipped in November of this last year with Twitch streaming built directly in. If you look at the controller, you notice in the upper left, I think I have a laser pointer here. The button here is actually labeled Share, and pressing that button allows you to share your content online through various sources, including broadcasting live on Twitch. The PlayStation 4 has an optional camera accessory that allows you to embed your own image while playing the game. The camera accessory was so popular due to Twitch streaming that it was nearly impossible to get for months after launch. I actually just got the camera myself the other day. But the president of Sony Worldwide Studios was quoted as saying about that shortage that it was a total miscalculation by marketing guys, and using the camera to broadcast yourself is much, much more fun than they thought it would, and just didn't quite get it. And I can identify with that. It doesn't seem logical at first that this is as fun as it is, but it really is. Also, the Xbox One launched around the same time as the PlayStation 4. And in mid-March was updated with Twitch streaming built directly in. Unlike the Sony PS4, though, the Xbox comes with the camera as part of its Kinect accessory, so there was no shortages on camera. There is no share button on the controller, but with the Kinect's built-in speak recognition, broadcasting is just as simple. Just saying Xbox Broadcast, and the Twitch app snaps to the side of the screen and allows you to broadcast and to interact with your viewers. This video is actually of me playing Peggle on Saturday. And we also offer the Twitch Broadcast SDK. This is for developers who develop games for platforms that don't necessarily have Twitch integrated streaming built in already. It's available on these platforms and available on our GitHub account. This is essentially gives the developers the ability to broadcast their game without having to worry about the ins and outs of codecs and protocols. It also integrates with our chat system that allows the developer to build chat directly into their application so you can communicate with their viewers, and as well as browse streams of other people playing the game that you're playing currently. So I'm going to go into a demo here. I'm going to switch over, bring up our web page. Excuse me, it's hard to see the screen from here. So this is all live. This is our website. So on our homepage, this obviously we have some featured content from a handful of streamers. I'm seeing if I know any of these personally. We have many streamers, so there's many that I don't know. So just looking around up at the top here, we have our Go Turbo button. We offer a service called Turbo, which is a monthly subscription service that allows you to watch ad-free. Our featured streams down here, user and comments, some featured games, etc. So if I go into a particular user, oh, and word of warning, this is live. I don't know what people in chat are going to say, so just if you're sensitive, you might not want to look. We loaded an ad up here, so this is our ad system in work, so it's playing this ad through. At the bottom, the streamer gets an opportunity to customize their page. We have a follow button similar to Twitter. If you're following someone, you'll be able to get notifications of when they go live, etc. We have a partner program where we do a revenue share with large partners. So this particular streamer is a partner for us. So if you subscribe to his channel, you can help support the streamer. We've actually generated a number of people who make a living now streaming video games specifically on our website. This particular video has 226 viewers right now, so not very many for us. I'm going to go over to the game section. So this is all the games that are currently being played right now on our site. So League of Legends, keep in mind we're on East Coast time right now, so we're kind of at the tail end of European prime time, and West Coast still hasn't woken up, so these numbers are a little light. So League of Legends, there's currently about 87,000 viewers watching that game. Dota 2 has about 33,000, and it's going down from there. If we go into individual channels, the top channel right now has about 20,000 viewers. So I can click on there, see what's going on here. Again, website setup same as before. We have our transcoding options, so let's see if we can go to source. So our partners and as well as very popular streamers get transcodes from us directly for free. We also have our video section. So this is past recordings or clips that this broadcaster has made. So I'm going to load up my personal channel here, which is twitch.tv, my last name, which is Szatmary. If any of you have laptops and you want to go, feel free My last Szatmary. And Justin, who's sitting right here, is currently logged into my account playing a game of Asphalt 8 off of an iPad. So there he is. That's live for those you can see him. We currently have 0 viewers. But this is streaming live off an iPad. For the people who are sitting right behind him, you'll notice there's a little bit of a delay on the iPad. There's some encoding on an iPad is particularly tricky. Apple restricts a lot of the APIs, so getting access to that hardware encoder poses a lot of challenges. I can go into more specifics on that during the Q&A if anyone's interested. How you doing, Justin? You're in third?
Yeah, it really got me.
Yeah, the quality is a little bit pixelated here. We're actually broadcasting not at the highest setting. We're having some trouble getting kicked off the network for some reason, so Justin's actually tethered to his phone right now. So we're broadcasting at medium quality to avoid getting bumped off. Okay, great. Thanks, Justin. So this interaction between the broadcaster and viewer is really starting to change the landscape of gaming. In February of this year, there was a phenomenon on our website called Twitch Plays Pokemon. This was not something we did. This was an independent developer who's choosing to stay anonymous. He created an application where he tied a Game Boy emulator to an IRC client. Our chat system's based completely on IRC, and allowed users to interact with the Game Boy emulator by typing commands into our chat window. So on the right, you see all the commands coming through the system in real time, and on the left, you see the character in the game responding. It took 6 days, 7 hours, 45 minutes, and 30 seconds, but they did beat the game. By the end, the single channel racked up 36 million views with a concurrent viewership of around 120,000. We got monumental interest from the press. We were mentioned in many outlets, including NPR, Wall Street Journal, CNN. There was a student who was studying the sudden organization of groups to make a decision who was asking for our chat logs for his research. It was a really interesting thing. So after this, other entities took note. Sony, for example, added an integration with their game Dead Nation. This is a zombie battle game where people in your chat can vote on different effects, like spawning zombie attacks to come and get you, or helping you out by giving you ammo. And in the game, the zombies are named after the people in your chat, so if you don't like the way they vote, you can take your revenge. The game Daylight is also another zombie-style game where you can, via chat, try to scare the person by, if you type footsteps, they'll hear footsteps coming up behind them. There was a game called Choice Chamber that was launched on Kickstarter. This developer actually started pre-Twitch Plays Pokemon, but the press from that helped him get a game funded. The difference here is he designed this game from day one for full Twitch integration, very similar to the other systems where there's a voting system where you can vote on what weapons to give the person, what enemies they may encounter. You can also help them out by building a bridge by typing the word bridge, and all the bridge bubbles pop up and they can walk across it. I think he's still under development, but there's some people who have beta access, and you can probably find some streams on our website. So the numbers, Dan mentioned a couple already, but I'm going to go a little bit deeper. So this is actually a report from an organization called Superdata Research. It's actually downloadable at superdataresearch.com. We're not affiliated with them in any way, but I found the report very interesting, so I'm going to highlight a few points out of it. Executive summary, I'm going to skip that. So they list here Starcade in 1982 as the beginning of competitive gaming. Starcade was actually a TV show, so if it was on TV in 1982, it obviously predates that in conventions. In the lower left, you'll notice they mention us in big letters in 2011. So esports viewership doubles year over year. So in 2013, there were 71.5 million people watching esports. League of Legends, as Dan said, Season 3 World Championship had 32 million viewers, beating out NCAA Finals Game 7 and NCAA Final 4. So the average esports viewer spends 2.2 hours watching video when they sit down to watch it, and they come back 19 times a month. This is a slide on revenue for some specific competitive games in the industry, and just about us. Again, it's available at superdataresearch.com if you want to read the whole thing. In January of this year, we posted our 2013 retrospective on our blog. I'll just go through some of those numbers here. We announced we had 45 million unique viewers per month, that with 1 million unique broadcasters per month. That was 2013. I know that this number is up to about 1.2 or 1.3 million broadcasters now. 13 billion minutes watched per month on our site. That's 24,700 years of video every month. 106 minutes per person per day, and 58% spend 20 hours a week, which is a little under 3 hours. It's 3 1/3 hours if you take one day off. 54,000 average primetime viewers. This is comparable to channels like Sci-Fi, MTV, and TNT. And 68% of our viewers have decreased their television consumption. And we've had 10 million installs of our iOS and Android mobile applications. So in February, the Wall Street Journal published an article titled "Apple Quietly Builds New Networks." And they didn't mention us in the article, but in their infographic, they showed Twitch as the 4th largest internet bandwidth user during prime time with 1.8%. As Dan said, various places report that number a little bit differently. But with 1.8%, obviously, we're in number 4 there, beating out even Hulu. One thing I'd like to point out, though, is with the possible exception of Google in this slide, but not really, we're the only ones who are actually doing live content. There's a company who makes caching proxies who published a report by mining their data logs, and they found of live video for their users, Twitch was 43.6% of the live video, WWE being second with 17%. And Justin TV is also on there with another 1.2%, that's part of our traffic as well. So going into the tech a little bit on how we do this, I'm actually going really fast, so we're going to have a lot of time for QA. So going into the tech, first, of course, is the challenges. So in 2013, we grew by a factor of 3. So obviously, scale is a big issue with us. And with those numbers I gave you earlier, I really don't need to say more than that. Delivery and storage is just extremely demanding. Live is different than VOD. There's nothing pre-processed. Data comes in and it needs to be dealt with then. Transcoding, you have 33 milliseconds to get through a frame before the next one's right behind it. Audio comes in equally as fast. Errors have to be dealt with in real time. If you encounter an error, you can't bail out. You have to deal with it. With VOD, you can take a little extra time to transcode. Matter of fact, it's probably better to take a little extra time to transcode, get your bit rate down, because you're going to see that savings in bandwidth over time. But when there's just more video coming right after that, it's more difficult. Interactivity. So live content is experienced as a group. Sporting events, news, concerts, these things are discussed in real time as they happen. We have our chat system. The viewers are talking to each other in real time. The broadcaster is aware of the chat. They're responding to the chat. It's a symbiotic relationship that needs to be maintained. And then UGC RTMP. This is, I didn't know what to call this bullet point. If any of you are engineers out there, you've heard of the term garbage in, garbage out. With live, it's garbage in and gold out. There are many RTMP implementations out there. Many of them are pretty poor. And it's not really the developer's fault on those systems. The RTMP spec is vague. There's details left out. We found cases where even Adobe doesn't adhere 100% to their own spec. And because of that, we get a lot of different type of streams coming in. We get a lot of incorrect timestamps. I get a lot of Annex B conversion done correctly in the AVC stream, if any of you are familiar with that. That's especially true from cheap hardware vendors. a lot of misinformation about the actual data that's coming. There might be a tag that says, I'm going to broadcast at a certain bit rate, and then it's not that, or a certain codec, and then a different codec comes through. And that's very challenging. So on the content delivery side, we actually do deliver most of our own content. We have about a dozen POPs throughout North America and Europe, and we do augment that with third-party CDNs when applicable. On the VOD side, we archive all streams temporarily as they're broadcast to us. This is a tremendous amount of data. Users can then generate clips using a highlight tool or archive the entire stream, and then these archives and clips are then available on our site or can be exported to third parties. So in 2013, again, as I mentioned several times before, it was a very big year for us, and we recognized very early on in 2013 that the video backend would need major enhancement to keep up with this demand moving forward. RTMP was starting to become a liability for us. So in 2013, we had an RTMP in, RTMP out system when we did HLS transcodes for mobile. But in that year, we moved to HLS everywhere. Why? So many of the playback platforms mentioned previously were added in the last 12 to 24 months. And having the video on every device, regardless of destination, has many benefits. We wanted to make sure if you were broadcasting, on PS4, you could watch it on iOS. And having multiple pipeline for multiple devices, especially for live, just becomes very difficult because, again, you can't put off the processing later. Multiple encodes take a lot of time. Scale and improve the quality of service. We really think of this at Twitch as two sides of the same coin. With large events, we may know ahead of time, but with most individual broadcasters, which is actually some of our most popular content, we don't know when they're going to go live. They'll just pop up live, and there'll be a flood of users coming in to watch them. We also have a significant amount of viral events. Like I mentioned, Twitch Plays Pokemon. This came out of nowhere. Even the developer of Twitch Played Pokemon had no intention of it being this big, but it got that big. So with RTMP being a long-term TCP connection, it really complicated elements on our edges. So it was difficult for us. We couldn't reroute a viewer. Once the user was locked into an edge server, they were there. There was nothing we could do about it without interrupting the content. HTTP allows us to maintain a virtualized backbone management where we're able to oversubscribe links and the bandwidth can go unutilized until the request from that content actually goes through. And we can adjust that map on the fly as people stream up and stream down and as viewers come in and as channels become popular. HTTP also eliminates a lot of state tracking from the edge servers. With HTTP, the server is actually maintaining a lot of information about timing and metadata for each individual broadcaster. With HTTP, as soon as the segment's delivered, the server can forget about that and move on to handling the next segment. This alone, on our blog, we stated that this was a 15% increase in throughput on our edge servers, but that was when we switched off of a 5-year-old RTMP system that was under active development and optimization for the full 5 years, and we switched to something brand new. Since we announced that 15% on that blog post, we've actually improved that number to about 50% improvement of throughput per edge. So we're getting a lot more done and less hardware on the edges. HTTP also gives the client the ability to rebuild its TCP session if it needs. If it has a bad route it doesn't like, if the TCP windowing becomes an issue, it can shut down that connection and start a new one. So it empowers the client more as well. Software and tooling availability. RTMP is a little stagnant. It's been around for a while. A lot of companies are moving off of it, including us, obviously. And the tools just aren't keeping pace. HTTP is every year something new. I believe Varnish and Nginx have both done major releases this year. The HTTP system's just moving forward just as rapidly as it's always been. And that existing tooling makes our jobs easier. And of course, enabling new features. So with HTTP and HLS, not specifically, but it enables us to do new features such as ABR, and we also have a lot of new things that we have not announced yet that's going to enable us to do. So how we did it. So let's see, in March of 2013, we started development of a proof of concept HLS in Flash. Our website being our #1 place that people consume our content, that was priority. We developed this in C++ and compiled it to ActionScript bytecode. In June, we started working on an in-house transmuxer, and as I said before, we can't transcode everybody. We'll sometimes have over 10,000 simultaneous broadcasters. There's just not the CPU power to do that. So we had to make sure our transmuxing was done very well and done correctly. So to make that a first-class citizen in our site, we developed it ourselves. That was working really well for us in our testing. So in August, we decided to push ahead and announce to our users that we now needed them to switch over to HLS-compatible codecs. So in the RTMP Flash world, since those are sort of two components that fit together so nicely, anything that's RTMP compatible is Flash compatible. Well, that's not true when you're transmuxing to HLX segments. So we had to get the users who are broadcasting with codecs like VP6 over onto AVC. We had to get them broadcasting with keyframes every 2 seconds. That was new for a lot of broadcasters. We had to get them on AAC and off of Speaks and other audio codecs such as that. 160 kilobit max comes from the Apple recommendation. During a lot of this development, I used iOS devices, my lowest common denominator platform. MP3, we support 44.1 kilohertz only. This was an intentional decision that we made because, first of all, we actually didn't want to support MP3, but we got some pushback from some software vendors who couldn't use AAC for whatever reason. I was actually having some problems transmuxing some of the content at different sampling rates, and Apple's documentation was a little screwy about this because they said they support MPEG-1 audio layer 3. Well, some frequencies are technically MPEG-2 audio layer 3, even though they have the MP3 extension. When I asked Apple about this, they told me to use AAC. So, so we decided just to lock it down to one frequency, and that simplified all our testing, and we can support that. And if you're broadcasting that, we can guarantee it works. And we took this opportunity to remind everyone to use CBR, which if you go to some of the other events today, I'm sure a lot of the people the broadcasters will be saying this as well. This is largely due to just the client side actually becoming either via TCP windowing or the adaptive bitrate switching, just becoming accustomed to certain bit rates. So if the bit rate fluctuates too drastically, you'll see a lot of buffering events. Quick anecdote on this, we had an integration for a popular game, and there was an issue that wasn't detected during testing, but when it went live, when the game transitioned from a waiting state to gameplay, the bit rate would spike, and it would hold there for a few seconds. It actually spiked to about 30 megabits. So we had viewers coming through, and the HLS player was downloading a 500K segment, and then 500K segment, and then a 17 megabyte segment, and then a 17 megabyte segment, and then a 500K segment. So whenever the game would start, the stream would stop. So that's fixed now, of course, but that's just an example of where keeping a nice constant CBR prevents those issues. So in September, we started our A/B testing by randomly assigning broadcasters to HLS endpoints. We didn't get a lot of feedback from this, which we took as a good sign. Not a lot of people noticed, and our logs appeared that things were actually just as good, if not better, as the RTMP system. So in November, we ran a single large event, DreamHack, on the new HLS system. DreamHack is the largest gaming festival in Europe. It's held in Sweden. The test results we had were that we had a lot fewer buffer empty events. So the green is the HLS system. Now, a buffer empty is, obviously when there's a buffer underrun in the player side. This is probably due to two things. One is just the extra efficiency we added in the HTTP delivery, but also we had some additional buffering in the player, so that was part of these numbers as well. And I'll get into that a little bit more in a second. And then so early to mid-December, we decommissioned all of our RTMP encoding and edges, and at that point forward, we were 100% HLS everywhere. And then in February, we fully retired. I forgot to mention that earlier. When we developed our transmuxer, the transcodes were still being handled by FFmpeg. But in February, we retired FFmpeg encodes in favor of a transcoding pipeline that was built into the same pipeline that the transmuxer was built on. This is a slide I did from an internal presentation about that transmuxer. I'm sure a lot of you have seen block diagrams before. But this just highlights out how there's the low CPU usage transmux side with the high CPU transcode on the right and top there. So this just demonstrates that we can, for popular content that we want to give multiple bitrate and adaptive bitrate switching to, we can spin up these transcoders on demand and keep the transmux going for the source. We do a couple things different than any other segmenter out there does. And this was, again, part of the design from the beginning, is when we segment before transcode, we take our cues from the streamer. Where do keyframes fall? Where should we segment? Obviously, we put limitations on that. If the stream is out of whack, we do our best to bring it back in. But by doing the segmentation before transcode, we're able to keep the transcodes and the transmux streams into the same adaptive stack and smoothly transition between them on the fly. We can produce smaller file sizes because the FFmpeg TS code is highly inefficient, and some other benefits as well out of our transcoder. So externalities, we didn't really encounter any problems we didn't expect. That being said, there were things that came up. Again, we expected them to our users. That isn't really useful that we expected them. But you can't wait till everything's perfect before you launch. Otherwise, nothing will ever be launched because nothing is ever perfect. But one of these things that was big is that, for us, is that the problems present themselves differently. So in RTMP, when you'd buffer underflow, it would kind of spit and sputter. Audio would pop in and out. Video would go down to very low frame rates. But it would still kind of appeared to be playing and struggling through. With HLS, it's a stop and a buffering state. So even though it's the exact same cause, the user saw new behavior. So they assumed something new was going on when it was actually nothing new was going on. This, of course, can be reduced by using adaptive bitrate switching. So instead of buffering, it should be switching down to a lower bitrate. And when these buffering events did occur, sure, the users who had them weren't really thrilled. But according to our logs, the number of events that occurred actually did go down by 80%. Time to live, which our users have come to call delay. So in HLS, this temporarily increased. This has been a hot issue for us. So with the interaction between the chatters and the streamers, a lot of times the chatter will say something in chat, and then the person streaming will respond. And it'll take some time for that. The broadcaster will see the chat immediately, but then the response will take time to get out to the edge. And this increased under the HLS system. Again, we knew it was going to happen. The problem is there's no silver bullet to solve this, because there's not one place that this was introduced. There's a little bit added in the segmentation. There's a little bit added in the player. There's a little bit added in the CDM. And we're working really hard to reduce this. We're pulling out 100 milliseconds here, 100 milliseconds there. Our viewers are starting to recognize that the streaming's coming down, but since it comes in 100 millisecond bits and not seconds, it hasn't been noticed as widely as we want. We have big announcement coming up soon, which will cut this out dramatically, and it's something we're working on literally every day to improve. And then, of course, our VOD system. So our VOD system and the RTMP system grew up together. And since we retired the RTMP system, there's now a little bit of an impedance mismatch between our VOD system and the new HLS system. So this is a major area of development for us, and we're working towards some new exciting things. And keep your eye open in the future and see what we announce. So I went, like I said, pretty fast there. So that's all I have. Thank you very much.
So let's take some questions. If you would, raise your hand and I'll bring the microphone to you.
Actually, while we're waiting, I have a question for you guys. Before Streaming Media East, how many of you have heard of Twitch? Little less than half, it looks like.
Who has a question? Right here.
website for the research report?
And repeat that for the video. What's the name of the website for the research report?
The website that had that research report is superdataresearch.com.
Question here.
Yeah, when you guys decided to go to HLS, did you look at Dash?
Yes. So let's see. Dash. Yeah, we did. Well, yes. So, yeah, we don't consider Dash ready for prime time. Again, the reason we switched to HLS, the number one reason was same stream on every device. Dash is great. Dash is probably the future, but it's not the present. You can play, there's this media source extensions that'll play on modern browsers, but not older browsers. Firefox doesn't have H.264. iOS won't play Dash. And matter of fact, even if I wrote software to get iOS to play Dash, the odds of Apple approving that in the App Store are about 0. So it's a lot easier for me to get HLS to work on a PlayStation and on an Android and on a Roku and on anything you can name than it is for me to get Dash on an iOS device. iOS is massive. 170 million iPads out there, 421 million iPhones. 77.2, this is research that came out on April 23rd, 77.2% of tablet browsing on the internet is on an iPad. It's a market you can't ignore. And the whole thing was we were aiming for a single distribution platform to just reduce the everything necessary to deliver. Doing 2 separate platforms just impractical for live video. If it was VOD, sure, I'd be all over it today. We'd be delivering it today. Also, since we deliver most of our own content, it would also double our backbone. So sure, we can get it out to the edges, but our edge for VOD it's different, obviously. But for live, content is only hot on the edge for a few seconds. So there's not a lot of benefits that you get out of caching. So having that double bandwidth over the backbone is impractical as well.
Another question here. By the way, I saw a lot of people snapping pictures of this cartoon. It's xkcd.com.
That's XKCD, if you guys aren't familiar with it.
Right here.
Could you talk a little bit about your player development strategy and how you keep a consistent feature set across devices?
Sure. So this is actually a serious challenge. I'm going to take that slide off the screen. Sorry. So yeah, this is definitely challenging from a perspective of multi-device. So in general, though, we tend to develop the players more for the user experience that the user is expecting on that device more than a standard user experience. So our iOS app does look different than our website, which does look similar but different to the PS4. But the PS4 app looks like other PS4 apps. The Xbox One app looks like other Xbox One apps. The iOS app looks like other iOS apps. So we kind of tailor more towards the device themselves and the player.
And then in terms of the team you have working on those, is it like a horizontal team across devices? How do you keep everyone kind of on the same page?
So how are we organized in terms of player development teams? So we have a group that we refer to as the platforms team, and this group is highly specialized for our platform development. Developing on a lot of these platforms is different than developing on a PC. Memory usage is much more of a concern. CPU usage is much more of a concern. Even on the game consoles, they're powerful, but you get a limited amount of CPU resources because the game console is holding most of them for the gameplay. So we have a team called Platforms Team, which specializes in these embedded device-style environments, who do most of those integrations. Our actual web player was a kind of a floating position. It was someone who worked kind of between platforms and the video, which are separate teams, and the web team. We've just recently actually reorganized that, and that position is now part of the platforms team as well.
Hey, cool demo with Asphalt 8 running on the iPad mini.
Thank you.
Pretty sweet. I'm from the devices side, so I'm actually kind of interested. For broadcasting live via mobile device like an iPad or an Android tablet, like what would you say is the ideal encoding performance from that device? Because you mentioned some encoding peculiarities with the iPad.
Yeah, the iPad is an interesting one in particular because Apple doesn't let you integrate directly with the hardware encoder. There's no API to do that. The only API essentially says make an MP4. Well, an MP4, if you're not familiar with the binary format, is not streamable. It's pseudo-streamable, but not streamable. It can't be streamed until it's completed. And because of that, because that's the only way to get broadcasting on iOS while, again, getting through the App Store, you can do it, but Apple will reject it for using invalid APIs. You have to record for a little bit, set the file aside, start file B, and start broadcasting file A, and swap them back and forth. As far as encoding profiles, it's really whatever the chip can do. We don't really recommend high too much unless you are high profile in AVC, because unless you are a partner or popular enough to get transcodes, if you're only getting transmuxed and you're broadcasting in high profile, you're going to limit your viewership to more modern devices. I mentioned the sales numbers on iOS devices. Android has more. There's about 1 billion of them, so about 300 million more. But a lot of these are the freebie phones at Verizon, and these phones cost, Verizon's making a profit giving them away. So they're not very expensive phones relative to a $700, $800 iPhone. So we can't really trust the hardware as much. So again, we recommend, baseline or main profile unless you have transcodes. Obviously use the hard, especially on something battery powered, we basically require there to be a hardware encoder. Otherwise, you're just going to burn through the battery and the phone's going to heat up in your hand. Does that answer the question?
Yeah.
Good morning.
Morning.
Of your 1 million unique broadcasters per month, if I noted that correctly, do you have any data, or can you break it down in terms of what your users are using? I'm particularly interested to know if you have a percentage that are using multi-cameras or using video switchers to broadcast.
I don't. We can probably speak anecdotally. Justin, do you have any anecdotes? Justin works a lot with the bigger streams, so a lot of the more professionally, this is Justin, everybody, a lot of the professionally produced content. So no comment. No, actually, I'm not sure if we've collected any data on that in general. It would be pretty, for the big broadcasters, we have an idea. For our real popular stuff, I'm sure someone in the company knows. But again, with, on average, 8,000 to 12,000 simultaneous streams, there's just not enough manpower. And determining that, we can try to detect what hardware is streaming to us based on the metadata that's coming out of the RTMP stream. But that is the easiest thing in the world to spoof, so we don't know if it's real. Because of problems with RTMP broadcasters in the past, a lot of them just pretend to be Flash Media Live encoder. So it's really difficult to know. Again, I'm sure we know for the big guys, but not for everyone. That being said, OBS and XSplit are very popular among our broadcasters.
If I understood correctly, you took primary responsibility for the delivery part of your network rather than using other CDNs. Can you just talk about what drove that decision?
I can't talk about exactly what drove that decision because it actually predates me. That CDN started being built in the Justin TV days back in 2005. I don't know. I would look at the market at the time and the how it worked at the time. We've just found that it's entirely helpful. We've really have I don't want to say build over buy because that's not true. We buy when buying makes sense, but we also build when building makes sense. And we don't shy away from hiring the right engineers to get the job done well. So the exact reason, I don't have an answer, sorry.
We have time for probably 1 or 2 more questions right here.
What's the distribution geographically look like, both in terms of your broadcasters and also your viewers?
I don't have those numbers with me, so if you want to hit me after, I can get you in touch with our PR person. Europe and we're global, so gaming is huge in the Koreas. Europe and North America is very popular. We have the, World of Tanks, which was one of the games mentioned in the Super Data Research Report, is very popular in Russia. So, oh, that is kind of ironic. I never thought of it.
How do you decide when to transcode, what content to transcode, and how much time do you need to set that up?
So if you are a partner with us, meaning we have a rev share with you, then you always get transcodes no matter what. You stream, you get transcodes. Other than that, we just sort our broadcasters by number of viewers going out and start handing out transcodes till we run out of CPUs.
Great. Final real quick question, and then we're going to open the exhibit hall. We'll have coffee in there. Are we really going to see, and maybe we already are seeing, Trump playing Hearthstone being better than, watching the latest series on NBC, CBS, ABC? Is that going to happen?
Justin?
Probably one day.
Probably one
Probably
day.
one day.
All right. The exhibit hall is now open. Coffee. Matthew, thank you so much.
Thank you,
Nice round of
everyone.
applause.